Okay, let's discuss this more comprehensive question. It has actually several parts that will work separately. We have a softball that was tossed such that its initial velocity is 10 meters per second. Its initial vertical velocity is 10 meters per second. Initial horizontal velocity is 20 meters per second. What is the resultant acceleration of the ball after it leaves the hand? What is its vertical velocity 0.2 seconds after it leaves the hand, and so on. Okay, now let's answer the first part. What is the resultant acceleration of the ball after it leaves the hand? The minute it leaves the hand, the ball is subject only to the gravitational force, meaning its acceleration is going to be 9.8 meters per second squared in the downward direction, or g. Okay, we'll use 10 in the calculations in a second. What is the velocity 0.2 seconds after it leaves the hand? 0.2 seconds after it leaves the hand, we are going to have to use these equations, except for the y. We know the time, we know the acceleration, we know the initial velocity along the vertical. Okay, let's go back to our slide. So our v y at 0.2 seconds is going to be equal to Vy initial, the initial velocity along the y, plus a sub y times t. In this case, Vy sub I, the initial velocity along the vertical, is 10 meters per second. A sub y is minus 10 meters per second squared, and t is 0.2 seconds. So that leads me to 10, and here we have minus 2, so that will lead me to 8 meters per second. That's the vertical velocity 0.2 seconds after it leaves the hand. What is the vertical velocity when it reaches the topmost position? I don't need to do a calculation for that one. It's going to be just 0 meters per second. That's the topmost position. What is the horizontal velocity 0.2 seconds after it leaves the hand? Since there is no acceleration along the horizontal velocity at 0.2 seconds is going to be the same as the initial horizontal velocity, or 20 meters per second. What is the horizontal velocity when it reaches the topmost position? Horizontal velocity at any time is 20 meters per second, since we don't have an acceleration along the horizontal. Okay, let's go on. What is the horizontal displacement during the first 0.2 seconds after it leaves the hand? Okay, so again here, we go here. Now, we are talking about horizontal displacement. So this is the equation we are going to be using, or remember, displacement is dx. So that's the equation we are going to be using. Okay, so our equation dx is xf minus xi. It is going to be 1/2 of a sub x t squared plus vix t. Now here we know that our a sub x is 0. Our t is 0.2 seconds, so dx at 0.2 seconds is going to be just 20 meters per second, our vix, times 0.2 seconds, which leads me to 4 meters. Then the next question: what is its vertical displacement during the first 0.2 seconds after it leaves the hand? Okay, for the vertical displacement, we are going to use the same equation, but for the y. So it's going to be yf minus yi, and it's going to be 1/2 of a sub y t squared plus vi sub y t. Now here, dy at 0.2 seconds, that's going to be 1/2 a sub y is minus 10 meters per second squared. That's the acceleration due to the gravity in the downward direction. And the time is 0.2 seconds squared. And then vi sub y is 10 meters per second times t, which is 0.2 seconds. Okay, here what we come up with, half of 10, that's minus 5 meters per second squared. And then we have 0.04 seconds squared plus 2 meters. Now here 0.04 times 5, that leaves us with minus 0.2 meters plus 2 meters. So that leaves us with 1.8 meters. That's the amount of displacement during the first 0.2 seconds. Okay, now the next question, how high does the ball go? Okay, this is, it entails gathering more information. What do we know about how high the ball goes? At the highest position, we know that Vy is equal to 0. And how high is a vertical displacement? So they are asking us to find d sub y when the final velocity is 0 and when the acceleration is minus 10 meters per second squared. So again, we'll go to the equations. Okay, let's go to the y component of these equations. These are my equations. I'm going to write down these three. D sub y is equal to 1/2 of a sub y t squared plus vi sub y t. That's one equation. V sub y is equal to a sub y t plus vi sub y, and the last equation, v sub y squared minus vi sub y squared is equal to 2a sub y d sub y. Now, from the information that we gathered here, we don't have any time. Now, if we don't have any time, the last equation looks like the most useful equation. We know the final velocity. We know also, I didn't write it here, but vi sub y, which is plus 10 meters per second. And we know a sub y, so we can solve for d sub y. Okay, let's write it down. In this case, 0 minus 10 meters per second squared is equal to 2 times minus 10 meters per second squared times d sub y. Okay, and here, this is minus 10 squared. That gives me minus 100 meters squared per second squared is equal to minus 20 meter per second squared dy. Divide by both sides by minus 20 meter per second squared. Okay, this cancels out here, the minus cancels out, the second squared cancels out, one of the meters cancels out, and we have 100 over 20. That gives us dy is equal to 5 meters. One question I could have asked, how long will it take it to go to the topmost position? If I asked you that question, then you would use this equation. We know Vy final, that's 0. We know Vyi, that's given here. We know A sub y, we just solve for